Hello. Long time no see here. I've been dying for the last month and a half. But either way, ended up just giving like a grand round 1 hour presentation on protozoal causes of hemolytic anemia for my residency and figured at least two out of the four super important to know. So I basically just kind of cut this down, trying to start keeping the videos less than 20 minutes, but we shall see. Okay, so Babesia and Cytosone Felis, and then very, very, very lightly going to touch base about Leishmaniasis and Sura. So Babesia, so it's an obligate intraerythrocytic parasite. In other words, that's why it's a cause of hemolytic anemia. It's transmitted by ticks, almost all the species. A few of them that we're going to talk about shortly haven't had an identified tick species. But also blood-to-blood contact, dog fights, and blood transfusions are associated with some of the species. They used to call it small versus large Babesia, and now they're doing it based off gene sequencing, and the names have changed a bunch of times. Zoonotic, it's not, unless you're talking about the rodent or the cattle species, but we're not. So here are the small versus the large. Probably the most important ones are Babesia canis, Vogeli, and Gibsoni. So for transmission, tick bites are the biggest ones that we think about. Dog bites, blood transfusion / blood-to-blood contact, and then a handful of species have been known to have transplacental transmission. So just the general life cycle, we're not going to go too crazy into it, but essentially the sporozoites are going to be in the tick bites and starts to feed, and as that happens, the sporozoites enter the bloodstream and invade the red blood cells. In there, they replicate via binary fission to produce 2 to 4 sporozoites that eventually are going to rupture the red blood cells as merozoites, and they can either go on to infect more red blood cells, or they can change into gametocytes, getting ready to hopefully, in their mind, be picked up by a tick to kind of do all of this again. So Babesia canis, it's a large species Babesia. It's found just about anywhere just because Rhipicephalus sanguinus, or this one right here, the brown dog tick, is essentially adapted to live anywhere, including homes, almost year-round. And then the ornate cow tick, which is over here, is Dermacentor reticulatus, is another big tick vector for it. The biggest thing that really is annoying, to be honest, when you're looking up information about the Babesia species is Babesia canis had 3 subspecies. So subspecies canis, Vogeli, and rossii. Problem is now they're their own separate species, and some of their names have changed again, which is annoying. So canis is what's called intermediate pathogenicity compared to like Vogeli and rossii. Rossii is pretty bad. Vogeli is meh. For Vogeli, it's a large species. As you can see on the left, there's a bunch of greyhounds. Kind of what I think about are greyhound kennels, so they can be found worldwide and most associated with this breed. And again, as you can see with canis, it's Vogeli is transmitted primarily via the brown dog tick. It's not very virulent. It's actually pretty common that when we're doing blood donor screening at NCSU to have like positive serology for it in these guys, which is unfortunate. But a couple cool things is that it's the only species found in pairs on blood smear. So it looks like 2 teardrops within a red blood cell. And then it was thought that Babesia is species specific, but there's a case report of Vogeli being found in a cat that was clinical in Vietnam. Gibsoni, which is now called Gibsoni Asian genotype. It's found primarily in the Midwest and the Southeast by the long-horned Asian tick, or the yeah. Clearly not super important, but primarily thought of like dog bites, blood-to-blood contact, pit bulls. This is like the stereotypical image people think about for dog fighting, unfortunately. Babesia coco, so it's kind of found along the East Coast and South Central US. It's transmitted via the Lone Star tick. Really, it was found within the last few years. The tick vector was recently discovered, and because it's not really Like it hasn't been around that much. There hasn't been that much research on it yet. Like testing and treatment aren't really that great right now. So Babesia vulpis, vulpis means fox. There's a bunch of different names, which is really annoying. But one of the bigger things to know is that dogs that tested positive for Babesia vulpis were commonly co-infected with either Mycoplasma and or Babesia gibsoni. This one is also associated with dog fights, kitties, and staffies, kind of like the last one that we talked about. But they might be renaming this to a completely different genus because Babesia should really only infect erythrocytes, but Babesia vulpis infects both erythrocytes and monocytes, which makes it interesting. And there's no tick vector identified yet. And then the last one we're going to talk about is Babesia conradi. This is also called Babesia gibsoni California isolate because it's only found in SoCal. There's no identified tick vector yet, but dogs, if they're going to present, would be like leukopenic, neutropenic. Dogs that do, I guess, survive treatment, kind of with like ANA treatment, which we'll talk about shortly, don't seem to relapse, but I don't think enough time is kind of surpassed. Kind of same thing with like cytosol that we'll talk about in a bit. And co-infections with mycoplasma species like mycoplasma hematoparvum or Hemocanis are pretty common in these dogs. They also happen to have increased contact with coyotes. So the pathophys, the hemolytic anemia, is primarily due to like the sporozoites, merozoites busting out of the red blood cell. But uh, as these kind of antibodies from the body start to ramp up, they can start picking up on red blood cell antigens and causing like a secondary IMHA. The thrombocytopenia is primarily due to consumption, but we can't really rule out that there is like a secondary immune-mediated destruction. Babesia species do cause an AKI. The most common is the membranous and proliferative glomerular nephritis, and then SIRS. So diagnosis, if you're lucky in the acute stage and you see the merozoites and blood smear, there's your diagnosis. You could do PCR to confirm, make sure that it's not other possible protozoal or infectious causes. In terms of serology, there's a bunch of different things, but it's not always wonderful. And two, does this stop them from being blood donors? It should. So the treatment, so for Babesia canis, Vogeli, and Coco, the standard's imidacarb dipropionate. It can cause cholinergic signs. So some people pre-medicate or get ready to treat with something like atropine, less likely glycopyrrolate. And then Gibsoni, Conradi, and Volpace are primarily treated with ANA or azithromycin atovaquone. That was established by Dr. Birkenhauer, which he's one of our internists. I think that study was in 2010 for cytozoan, so around that time. The best method of treatment is prevention. So tick control year round, even in the winter, everywhere you go, and still checking. When I used to live in New England, we were recommending that people get Bravecto and the Seresto collar. So, if the collar's not put on correctly, they can still get ticks that bite them. They can also bring ticks home, especially if you have like cats or other animals that don't have tick prevention. So the collar helps repel. Bravecto kills them if they bite. And then there is a vaccine, but it's in Europe and it's not 100%. But interesting. Hopefully we'll get it over here one day. Next is Cytozoan felis. So this is the only known pyroplasm of cats in the US, and it's transmitted by the Lone Star tick in Dermacentor variabilis, and it's endemic in the southeastern and the south central states, and it's expanding. It's not as fatal as it used to be. It used to be thought it was essentially 100% fatal. But then in the Journal of Veterinary Internal Medicine, there was a case series like a decade and a half ago or a decade ago about like 21 cats that did survive natural infection. And luckily, it's not zoonotic. So it can be any cat, no matter where they come from, what they look like at any time. It's primarily going to be outdoor cats. But again, if you have dogs that go outside and bring ticks inside, your indoor cat can still get infected as well. So the life cycle, it's pretty similar to Babesia, so we're not really going to hound on it too much. The interesting thing that I think is, so for the AP complexins, essentially they have to bump into host cells at their apex in order to like recognize, bind, and internalize. But cytozoan's interesting in that any portion, any orientation, no matter what, as long as it touches a host cell, can invade that cell, which I thought was pretty cool. So transmission, so Amblyoma americanum, or the Lone Star tick, it's primarily found along the tail or the perianal regions. And then Dermacentor variabilis, there's a study called Show Me Your Ticks, where it's primarily going to be like the head, the neck, along top line. But then a recent study, it was either the same one or similar, and that the cranial aspect of any of the limbs are also a good like hotspot for them. So again, the Lone Star tick is A, B, C, and then D and E is Dermacentor variabilis. And the pathophysiology is pretty similar to Babesia, but it does cause a pancytopenia in cats, primarily due to consumption, like from the white blood cells and the platelets. And as you can see right here, this was a vessel that's being occluded by a pretty heavily infected macrophage with the schizonts. And then cats do get interstitial pneumonitis, and that can be secondary to like severe inflammation and the neutrophils, but primary pulmonary pathology is also becoming more elucidated. So blood smear, you can kind of see these signet or class rings, and then a tissue smear is like a macrophage laden with a bunch of schizonts. So I put this up here because cytozoan does look pretty similar to other things. So Babesia and Theileria in cats. Luckily, that Babesia felis is not endemic, and it's essentially pretty rare in the U.S., but it's possible. And then Mycoplasma, which is way more common in cats. Remember that Mycoplasma is epicellular, so it's usually kind of like on the surface. It can have some signet rings, but those are usually towards kind of the edge. And then the hollow jolly bodies just kind of look like these little dots. So when in doubt, always get another blood sample and look again. And it never hurts to send it out. So PCR is kind of the gold standard other than like a presumptive. Serology is not commercially available yet. So treatment, so ANA, so this is when Dr. Birkenhauer and Dr. Cohn back in 2010 developed this study. And I think it was about 64% of cats that were treated with ANA survived, which is much better than, what, a 36% mortality rate compared to what used to be just about 100. So the kind of the cornerstones of treatment are ANA, heparinize, supportive, the less amount of touching, the better, right? So replace what's lost. So give them red blood cells, give them fluids, give them nutrition. You can tap them if you need to. This case right here is one of my cases that I had that had cytozoan. He went into high output heart failure, so he had to get some chest taps and whatnot. And even after the chest tap and the feeding tube placement, you can see that there's a lot of effacement. So still a lot of fluid, but after 9 days, he ends up going home and he's still doing really well. So recovery, so there's an in quote complete recovery if they do survive acute disease. However, these animals are known to be chronically infected or chronically parasitemic. The risk of relapse is questionable. However, there was a case report in JVIM that reported that a cat developed and survived cytozoan, and then 7 years later developed a really similar disease and was positive on all the testing. I can't remember if they were 100% confident that it was kind of like a relapse, but it's convincing enough to be pretty concerning. So with the family of the cat that I had, I talked to them and I let them know that, hey, we're going to spend a lot of money. He may not survive, but if he does, there's a chance of relapse. And I need you guys to know that because it's a lot of money and it's a stress on the cat and also the family as well. So just being very transparent. So prevention. So the Seresto collar and Revolution Plus are kind of like the big ones that you can find. They're pretty easy to apply. The Seresto collar is great in that it's good for, 6 to 8 months, depending on if it gets wet, but it may not break away. So if you have an outdoor cat, you might want to stick with like a topical like Revolution Plus and just religiously applying it every month. So just going to very briefly touch upon leishmaniasis, the Leishmania donovani complex. So it's a complex made up of infantum, donovani, plus or minus a mexicana. I mean, just like, look how beautiful this image is. Oh, so pretty. So essentially, it causes an extravascular hemolytic anemia, and it does impair erythrocyte membrane fragility, so they're more likely to rupture. According to the ACVIM consensus statement in the US right now, the evidence of it's pretty low, but it's still pretty important to test for it. The NCSU vector-borne disease pathogen lab does have a leishmania test that you can do, and it's important to rule out because it is zoonotic. And despite what most people think, leishmania is here, and it's coming and it's spreading. And then Sura trypanosoma evansii, like look at these, they're just so pretty. So it's transmitted via these disgusting, huge, painful biting bugs and vampire bats, primarily in South America. That also causes an extravascular hemolytic anemia. And cats that were infected, I think about 7 days later, developed like this pretty mild regenerative anemia that then just kind of like equilibrated and became normal again. But trypanosoma is zoonotic, so again, it's important to just keep in mind, especially with we've had globalization for all these decades and climate change and so on and so forth. So some important tips to get out of this that I kind of just breeze through is so all dogs with IMHA or AKI should be treated for babesia. Cats can become infected with the canine species of babesia. Cytozoan relapses are possible. Canine and feline babesia are not zoonotic, and then ANA treatment is the mainstay for most species of babesia and cytozoan. Again, with cytozoan being ANA, heparinize, supportive, the less amount of touching, the better. And then all animals, no matter whether they're strictly indoor or outdoor, should be on tick prevention because spending some money on prevention is a lot cheaper than spending thousands and thousands of dollars on treatment and not being guaranteed they will survive. And then leishmania is it's a coming and it's a spread. So hopefully you learned something from that really quick. If you want me to do something a little bit more detail oriented for this presentation, just let me know. But otherwise, hopefully you learned something. So like, subscribe, comment, do whatever you want. Share it, don't, doesn't matter. Thanks very much.